Welcome back to another sort of introductory video to vectors. We'll cover a few more things about vectors. Okay, so let's just start with the zero vector. Now, the zero vector is kind of important because when things add up to a zero vector, they all sort of cancel out. All the vectors sort of cancel out each other. In other words, there becomes no movement. If you're talking about vector as movement of an object or anything, there ends up being no movement. So how we write the zero vector is like this. It's a zero, and you write a little tilde underneath it. Okay, and what that is, if it's two-dimensional, that just means the vector 0, 0, like that. If it's three-dimensional, then the zero vector will be 0, 0, 0, and that's quite important to understand. And I'll just show you why. We get like what we call polygons of vectors. So polygons are just straight-sided shapes. Polygons of vectors. And so if you get a polygon of vector where you've got, let's say a vector like that, and a vector like that, and a vector like that. So we'll call this vector A, vector B, and vector C. What happens when you add up all these vectors? So we add this vector plus this vector plus this vector. Well, remember what happens is you start with a tail, and you add it together, add this one, add this one, add this one. In fact, it adds to nothing. If you add those three vectors together, they add to nothing because you end up where you started. Because if you remember, if you add two vectors, and if you add those two vectors together, then what you'll get is this vector. You start at the start and you finish at the finish. And so that's the vector. But here, you actually get nothing. You end up at the same spot. And so what we say is that A plus B plus C, those three vectors, what happens when you add them together? You get the zero vector. So that's equal to the zero vector. And that's quite important to understand. And that's just a polygon of vectors. You could have any number of sides, but if it ends up where it starts, you'll get a zero vector there. Let's also talk about parallel. So when are two vectors parallel? We've sort of briefly touched on this second video, I think. When are two vectors parallel? Well, you could have a vector like that, A, and you could have like a smaller vector, they're supposed to be parallel, B. Those two vectors are parallel, so do they need to have the same magnitude? No, they don't, to be parallel. What is the requirement here for A and B? So let's just say A was equal to, it looks like about 45 degrees, so let's just say 5, 5. And let's say that B is equal to 2, 2. Don't forget the tildes. So if you look at those two vectors, when are they parallel? They are only parallel if and only if we can write A as equal to some scalar multiple of the second. In other words, if we can write one vector in terms of the other vector just by multiplying it by some number, then we get parallel vectors. In other words, we can write A as equal to, now I chose bad numbers, but if we multiply it by 2.5, B, then, whoops, I'll just undo that. Let's press that stupid button on the pen again, it really ruins me every time. A equal to 5 over 2. So if we multiply B by 2.5, then we get the second vector. And so if you can write it where K is just some number, some scalar number, if you can write that, then you can write as parallel lines. And that's basically all there is to it. Yeah. Next thing I just want to touch on is position vectors. So I'll just try and draw my straight one. Usually pretty lousy at that. If you've got, say, a dot up here, a point up here A, and say a point here B, then we can actually write these as vectors. So if we want to say what is the vector of point A, what we do is we need to start from some point. So let's start from the origin, and let's just say that this is 3. This is doesn't really matter. And point B is 8, and that's 2. Okay. So what we can say is the point A, we can write a position vector to show us what is the position of A. So starting from the origin, what is the position of A? Well, we can define it with this vector here. What is that vector? Well, that vector is the vector, so OA, so the origin to the point A is equal to 3. It goes across 3. How far does it go up? It goes up by 9. And so we have a position vector as 3, 9. And that's what we call a position vector. It tells us where is the point A. So what's the position vector of B? OB is equal to, we always start from some point, and it's usually 99.9% of the time the origin. Okay, so that's, we need a common spot so that we can say what is O and what's where is A and where is B. OB is equal to, how far does it go across? It goes across 8. How far does it go up? It goes up by 2. And so that's our position vector of B, and that looks like, if I can draw it, not too terribly, that's that position vector there. And that's basically all we need to know about position vectors. We'll get more into them, but just remember that a position vector gives you the position of a point, and so very important to remember. And that's about it. I'll cover a bit more in the next video.